So this section, we learn a shortcut to figure out if two triangles are similar. And this works for triangles. Yesterday we kind of talked about all polygons. Today we're focusing on triangles and similar triangles. So the shortcut is if you can show that two angles in one triangle are congruent to two angles in another triangle, then you can say those two triangles are similar, therefore all of the ratios are proportional. Okay, so on the first question here, it asks if these two triangles are similar, and it's hard to read the numbers, so I'll just draw them. I think it's 81 and 60 for one of them. And the other is 40 and 81. They're oriented differently than this, but this is what it's saying. So how many angles or degrees are there in a triangle altogether? 180. And this is 141, which means this angle must be 39. Okay. And here, this is 121, which means this angle must be 59. Okay. You always, when you get a problem like this, always find the third angle of both triangles, because if this had been 40, then these two triangles would have been similar. But unfortunately, we have 81 and 60, 81 and 59, 81 and 39, 81 and 40. So these two triangles are not similar because they don't have at least two angles that are congruent. Okay. Question 2, are these two triangles similar? See the two triangles that were created there? Okay, what does the arrow mean? It means those are parallel lines. So this is a transversal, which means this angle and this angle are congruent. And this is a transversal, which means this angle and this angle are congruent. Therefore, two angles in one triangle are congruent to two angles in the other. Therefore, these two triangles are similar. Okay? When you write the similarity statement, let me write these. Kind of like the congruent statements we had to write. Triangle ABC is similar to what triangle? EDC, yes. Okay, so it gets a little tricky here when you have proportions. Let's say this is 3 and 6, and this is 2 and what? It's not this side of the triangle that's proportional to this side. It's this side that's proportional to this side. So just be careful. You're going to have to follow the order that you label your triangles when you're doing your proportions as well. Does that make sense? I would write this as 3 is to 6 as 2 is to what? Nope. What is to 2? Okay, the small one's on top here, so the small one has to be on top there. Or this triangle, I should say, is on top here. And this triangle is on bottom, so I'm making sure that my proportions are the same. And this is to this length as this is to this length because of the way we wrote our triangles. And then you would solve for x. Okay. All right, next question. To use indirect measurement, the units must be the same. Well, in the textbook, indirect measurement, the example they gave is if I have this tree and I have a person here, and I draw the height of the tree as one triangle and the height of the person as another, and I say these two triangles are similar, indirect measurement means if you can find the measurement of the person, is in this case, this is something that could be useful in real life. If you've got a huge tree in the back of your yard, and you can figure out the shadow length of the tree and the shadow length of the person, you could actually calculate the height of the tree without having to climb it with a tape measure using indirect measurements. So you're not directly measuring the tree, you're measuring something that you've created similar triangles with. Then you can use proportions. Okay? So if I know the distance of the shadow of the tree, and I know the distance of the shadow of the person, and I'm told these two triangles are similar, I can find the height of the tree if I know the height of the person, just using ratios. But the question here was, when you're doing indirect measurement, is it important the units are the same? And the answer is yes. Units have to be the same. I can't take inches over feet and compare it to feet over feet. I have to convert everything either to inches, or I have to convert everything into feet. In the example in the book, this person was like, 5 feet 10 inches. Everybody knows that means feet, that means inches. Okay. And the tree was, 20 feet. When I'm going to make my proportions, if I know that the shadow is, 40 in this case, and I know this shadow, if I were to do a proportion then, I would say 20, the height of the tree is to, that's what I'm looking for, so let's make that x. X is to the shadow length as the height of the person is to his shadow, but everything is in feet except for this. This is in 5 feet 10 inches. So I either need to convert those inches into feet and get a decimal for feet, or I just need to convert everything into inches. The point is, all units must be the same if you're going to do ratios. Okay? So that one would be true. To use indirect measurement, the units must be the same. In the know what section, George wanted to measure the height of what? Flagpole. And then how many videos were there? What was that? 1? Okay. So remember, classroom problems are being done in Canvas. You should have 6.2 done tonight, if you haven't done it already. Classroom problems in CK12, and then, or 7.2, sorry. And then 7.3 is tomorrow night. Okay.